Hello and welcome back. Today we are doing an adventure in segmentation. So what is segmentation? Well, what we want to do is we want to take this input and use machine learning to generate this output. But we're going to do a bit of a twist. So in this segmentation, the user is going to select an area of interest. And we're only going to train the system with 150 images, not like Google, who uses like millions of images, just 150. We're going to train it from scratch using no transfer learning at all. And I'm just going to use free compute, like what you can get off the cloud. And I'm going to train it in 45 minutes. So let's see how that does. Well, it was a good idea. So, what happened? Why didn't it work? And what is image segmentation? So, image segmentation is really, cropping an area, or rather, finding all of the pixels that contribute to a particular area of interest. So, we're going to start with an untrained model. And in our case, the user selects areas that they want to keep and areas that they want to remove. I used green because I'm going to change that to like a green screen. After I played with this a while, red usually, I keep using red to mean to remove the thing. Anyways. And we want to generate this mask. And then the mask is going to be used as a filter on the original image to pull out our target. And that's it. That's what we want to do, and that's kind of what we want it to look like. So, usually you use like hundreds of thousands of images, and you use some pre-trained net that can do general image recognition, but I'm lazy. I only used 150 images because after I segmented them myself by hand and cropped them, I was tired of doing that. And I'm poor, so I wanted to only use free compute because I don't feel like buying myself a cluster of 8 GPU mini supercomputer, which, if you want to do this on scale, that's what everyone says that you've got to do. And I wanted to try to not do that. And I'm impatient, so I wanted it to train 45 minutes. So there was a mistake. I didn't give myself like the 4 to 40 days it takes other systems to train. But most importantly, I'm overconfident. So I decided to train this from scratch and not use any reference. And that's a lot of what went wrong and why the image segmentation didn't quite do as well as I was hoping. So I took a second stab at this and I checked a reference. I did end up going and looking up UNet. Couldn't quite remember it all, but I did get the major parts correct. So what did I not remember particularly well? Well, I did remember it was 5 layers, but in that initial prototype I showed you, I only used 3 layers just to see if it worked. Maybe if I scaled it up to 5, it would have worked. I don't know. I just decided to look at the network. Second thing is I was using TANH instead of ReLU. Switching to ReLU, holy cow, this works so much better. So yeah, always explore these types of things and be open to trying different activation functions. Yeah, this was one. I was actually using, it recommends using 64 filters in the first layer and then doubling that as you go deeper into the network. So I just used 16 filters because that was a much smaller architecture and it trained really well. And I had to change the learning rate. I was using Atom with the default learning rate. It just would collapse the network super fast. So just decreasing that a bit improved significantly. And I was using 5x5 patches, and when I changed that to 3x3, it worked so much better, and 3x3 is what UNet suggests. And it was a much smaller model in the end. And unlike UNet, which just has one black and white input image, the input is 5 colors. So RGB is the first 3, and then the next color is what the user wants to keep, 2 suggestions, up to 2 suggestions. Actually, as much as you want, because it's a whole color map. So it could be however much the user wants to suggest. And then the 5th one is where in the image the user wants to suggest to remove. And once I put these in, it really made a huge difference. Let's start the training. You see around the businessman's shirt, it's having trouble with that. And the guy at the top holding something, it's having trouble figuring out that it shouldn't include that thing that he's holding. But it's getting pretty good. Look at that segmentation. That's really crisp. That is pro level, I would say. So I think that whole training took about 45 minutes after I got the architecture all set up. So how was this possible? Well, I'd like to say because I'm awesome, but that's back to the overconfidence thing again. No, I had a theory when I started this project that, if we used UNet and we add in user suggestions, that the machine learning would have a lot more information, that the user suggestions would really drive the early learning and let it just come to conclusions much faster. And we can see that when we pause the training and we take a look at the green arrows pointing at the predicted mask. You can see that where the user gave a suggestion that it wanted to remove that aspect, the machine learning took that information in right away. And similar with the red dots where the user suggested, hey, I want to keep that information. The machine learning already started putting in that mask and taking that suggestion into consideration immediately. So those user suggestions really bootstrap the learning tremendously. Hey, let's take a look at some more images. I had a lot of fun making this neural net and making this video. I hope to see you in the next one. Bye for now.